So today I'm talking about calculus. We're talking about integrals. All right. Integration. Okay. Now, typically when you learn calculus, you learn derivatives first, but I'm going to start with explaining what they are with integrals because I think it actually is a little bit easier to understand integration than the concept of integration than it is to understand the concept of derivation. Okay. And the truth is, you already know how to do calculus, pretty much, or do some forms of integration. You just don't realize that you know how to do them. Imagine I have a car. All right, I'm gonna start off at 0 feet per second, and I'm going to accelerate over 22 seconds to 66 feet per second. Okay. Then I'm going to stay steady at 66 feet per second for 100 seconds. And then we're going to then I'm going to decelerate from 66 feet per second to 0 feet per second over 11 seconds. Okay? Well, in this first one right here, we can see that my average speed, we present for our average speed is going to equal 33 feet per second. We want to find out how far I've traveled in this time. Well, my average speed is 33 feet per second. And I did that times 22 seconds. And that's going to equal 363 feet. Alright. Next, I am going to be slowing steady, so that's going to be 66 feet per second times 100 seconds. My seconds cancel. And that's going to give me 660 feet per second. Actually, I'm going to travel 726. Okay. And then I'm going to decelerate. So that, again, my average speed is going to be 33 feet per second times 11 seconds. And that's going to equal 363 feet. So 726 feet plus 6600 feet plus 363 feet. And that's going to equal 26 plus 6600 plus 363 equals 7689 feet. Alright? And so we can see the middle of the problem, but we're going to graph it and do some math, and we're going to see what calculus really is. Okay? If I start at 0, so this is this is time, t. This is distance, d equals rt, right? All right, but r is not a steady number. It's going to change a little bit. but that's okay. So we're going to start at 0 and over, so delta t equals, I need to write that bigger so you all can read it, can I? Okay. Over 22 seconds, I accelerate. I'm sorry, it's not d. I'm confusing you. This is rate. Okay. And so what over I'm going to accelerate up here to 66 feet per second. Okay. I'm going to hold steady for 100 seconds. And then I'm going to decelerate down to 0 again. Okay. Delta t equals 11 seconds. And so we see 22 seconds, 100 seconds, 11 seconds, okay? 66 feet. Well, if I wanted to find the area of this is going to equal 1/2 the base, which is 22 seconds, times the height, which is 66 feet per second. Okay? And we do that math, and we find out, whoa, this is 726 feet, because seconds cancel. Okay? Area 2 is just the base times the height. The base is 100. Sorry. Base times the height, which is 100 seconds, times 66 feet per second. A sub 2 is going to equal that 6,600 feet. Then finally, A3 is going to also equal to triangle 1/2 base times the height, and that's going to equal the base, which is 11 1/2 times the base, which is 11 seconds, times the height. My height is going to be 66 feet per second, and that's going to equal, seconds cancel out with feet, and that's going to equal the 363 feet. And again, 726 feet plus 6600 feet plus 363 feet. My answer is going to be, sum of A is going to equal that, or the sum of the areas is going to equal the 7689 feet. So we say in calculus, if we take the area under the curve, this isn't a curve as it starts as lines, but we call it a curve anyways. The area that is under this line, that's going to equal the distance traveled. This area under the line is what's called the integral. Okay? So look, it's been something you've been studying all along. Area under the curve equals the integral. Alright? And obviously you've done this before, it makes sense. Now the question comes, what are those formulas? Well, that's going to be the tough part. We'll show Lewis, let me show you here, look this paper out and give you a few more examples of what really happened. Okay, so we want to figure out, we give the example. we have our little we have our little chart where the car travels, accelerates, maintains a steady velocity, and then slows down. You're saying, well, Matt, that's really good, fine, and wonderful. But in reality, cars don't travel that way. Silly. I mean, cars will start go up like this, and even in the simple case of what we had before, it's going to do a little bit like this, and then it's going to decelerate. Okay. All right. So we can approximate it with this. If I want to get really, really exact, what would I do? Well, let's just supposing that I had, drawn this curve by taking little data points. Okay, so basically this curve was a section of points. Okay, and I had these points. Well then, okay, what happens is that each of these points, you connect all the lines in these points. What they all do is they all make a little quadrilateral that has this area. And this area is going to equal 1/2 times, I can draw something bigger. We got A1, this is A2, the last one's A sub n. Okay, and so the area is going to be the sum of A sub I equals 1 to n. Alright, and the A's, you remember this is 1/2. In this case, R of T1 plus R of R2 of T. Sorry, I don't want to do it that way. A equals 1/2 times, case A1, 1/2 of R, the rate at T1, plus the rate at T2, okay, divided by T2 minus T1, okay, and we say that's the area, but look really close, that's the area of that, right? Okay, this is A1 blown up. This is my rate at times T2. This is my rate at T sub 1. And this is my delta T. Okay? And we know that basically the area is the point is the average of these two right here times the base. Okay, and so we add these all up. And actually, this is how computers still do it. A lot of times in the real world, you just have a little bit of data points. Okay, you don't have an actual function. You have data points. When you have data points as opposed to a function, and you have a computer that can do calculations quickly, easily, and efficiently, in those situations, you're not going to want to go through the whole process of figuring out what the integral equation is. Okay, but years ago, and with certain functions, that wasn't always the case. We want to know what the integral was, and so there's actually a way to figure out that using these sums and limits and other good stuff. But that will be the topic for another video.